Ladies and gentlemen, this is your pilot speaking. We are prepared to make quantum dots. Please remain seated. Keep your arms and legs to yourself as the experiment commences. Gas masks used to be in front of you, but due to the cutback, are not anymore. Just like the garbage cans in class. If you happen to have seat belts on your seat, please do not fasten them, as it will prevent you from running in case of emergency. Speaking of emergencies, the emergency exits are located to the front and back of auditorium. Hopefully, we won't have to use them. Who am I kidding? We probably will. Here's our co-pilot, Colleen, to give us an outline of our journey today. Thank you.
Thank you, Shabazz. So first we're going to make our selenium solution. This solution is going to react with our cadmium to form quantum dots.
This just in. Sources say the selenium solution itself may not be toxic materials, but the vapors could in fact be irritating. Therefore, it is recommended to use it under a fume hood. Back to you, Colleen.
As I was saying, the selenium is placed in a vial and 5 milliliters of 1-octadecane and a little bit of triacetylphosphine are added. Then we gently heat until all the selenium dissolves. This is then capped and set aside for later. Alright, now it's time to make our cadmium solution.
Good afternoon, this is Shabazz with the breaking news. Cadmium is a carcinogenic. Back to you, Colleen.
Thank you. What we're supposed to say with that is that yes, cadmium is toxic, but kept under the fume hood and handled with proper safety measures in mind, it is acceptable to work with.
Under extreme conditions.
Under safe conditions, we take 13 milligrams of cadmium oxide and add in some oleic acid and 1-octadecane. We then heat it until the cadmium dissolves and then keep heating until the solution reaches about 225 degrees Celsius. Once the solution is ready, we add 1 milliliter of our selenium solution, give it a quick shake, and immediately start withdrawing portions of the liquid into waiting test tubes. By removing the solution from the heat, the particles stop clumping together and their size is fixed. By extracting quickly at the beginning and then with every significant color change, we get a nice range of different sizes of the same cadmium selenide nanocrystals. Okay, and now we have our quantum dots.
Thank you so much, Colleen, for this wonderful report. Now on to our next story. This shocking video reveals the true danger of this experiment and improper lab technique. How are you going? Yep. This is plastic.
Plastic.
Yes. So we just found out that the plastic pipettes don't work because the solution is 200 plus degrees Celsius. As you can see, it melted the powder. But good thing about this was we know that it changes color, so it was working. We did have some quantum dots.